the next strategy we're going to look at, we're just going to call it permutations with grouping, because restrictions, we've already used that word. Deal with the restriction first with spaces. So we're going to call this permutations with groupings, because sometimes you want to have certain groups of things together and still count how many ways you can organize something. Like, what might be something that you have at home? Maybe you have a lot of shoes, and you like to organize your shoes on a shelf to look at every night before you go to bed because you really like them, but you want to organize your shoes, but you're the type of person that you have to keep your black shoes together, and then you have to keep your brown shoes together, and then you have to keep your gold and glitter shoes together. So what happens is you have groups. You have to keep your groups together, and then you also have to arrange things within your groups. The strategy and the way of doing this is you first figure out how many groups you have. Black shoes, brown shoes, gold and glitter shoes. 3 groups. So you first make a decision, 3 factorial, what is the order that I'm going to put? Black ones first, or the glitter ones first, or the brown ones first, and so on. Then once you've organized your groups, you look inside your groups. You have 79 pairs of black shoes. How many ways could you arrange 79 pairs of black shoes? 79 factorial, right? You have 2 pairs of brown shoes. How many ways could you arrange your brown shoes? 2 factorial ways, 2 ways. And how many gold and glitter shoes do you have? 13. Yeah. So then you do your number of groups first, then group A, group B. Now, I can't necessarily relate to the shoe problem, but I want to arrange my calculus books, my algebra books, and my geometry books on a shelf. So I want to, and there are 4 different calculus books, 5 different algebra books, 4 different geometry books. So I have to first make the decision how I'm going to arrange it. Calculus first or algebra first. And so my first decision is how many groups do I have? I have 3 groups. I can arrange those groups in 3 factorial ways. Then once I've decided which group goes first, which group goes second, which group goes third, my next decision is how many ways can I rearrange my calculus books? My calculus books, there's 4 of them, they can be arranged in 4 factorial ways. How many ways can I arrange my algebra books? They can be arranged in 5 factorial ways. And finally, my geometry books in 4 factorial ways. Multiply all of those together, and we get the total number of ways. The groups are together. This would be the total number of ways they could be arranged on a shelf. So this is called a grouping question, because certain things want to be in a group. And whenever you have a grouping question, you first, if we go back, first do the number of groups that you have, factorial, and then you look at each group individually and arrange within those groups. So grouping questions can come about in a number of different ways. Example 2. 5 people, Amy, Bill, Jill, Lee, and Tom, are at a park bench. In how many ways can they be seated if Jill and Bill want to sit together? Ooh. So it's a grouping question because we have Jill and Bill together as one group. Oh, yeah.
No, you have to erase it. Make it red. Justin Bieber.
Okay? Jill and Bill want to sit together, and then there's still Amy, Lee, and Tom. They don't have to be together. So it becomes a grouping question because you have groups Jill and Bill together. In a grouping question, we say, how many groups are there? And the danger in this one is to say 2 groups, Jill and Bill and the rest. But do the other 3 have to sit together? No. So technically, we have 4 groups here because Amy, Lee, and Tom are individuals. And so for our number of groups, we would have 4 factorial. Then for each of our groups, we have the group with Jill and Bill. How many ways could they be seated? Well, they could hold left hand, right hand, or right hand, left hand. 2 factorial, which is just 2. And if you wanted, you could do 1, 1, 1 for the other ones, but you would not need to show this because there's only one way to arrange Amy in her group. She's just Amy, just Lee, and just Tom. So there's going to be 24 times 2, 48 ways they can sit on the bench where Jill and Bill are together. Part B. Now Lee and Amy also want to sit together. Don't worry, Tom gets his revenge in part C. Okay, it's coming. But right now we've got Jill and Bill, Lee and Amy, and Tom sitting on the park bench. How many groups do we have now? 3 groups. So 3 factorial for our groups. The Jill-Bill group, 2 factorial. And the Lee-Amy group, 2 factorial. And then Tom is just 1. We multiply all of this out, 6 times 2 times 2, 24 ways in total. Now, we don't know exactly what happened. Tom's revenge, not sure what happened here. But now they come back to the park bench, and whatever happened, now Jill and Bill must not sit together. Okay? And for part C, we're not Lee and Amy on again, off again kind of thing happening here. So we're not worried if they're sitting together or not. All we have to make sure is the 5 sit on the bench. I'm really surprised that both Jill and Bill still come to the park bench. But they're going to come to the park bench, but they're not going to sit together. So.
Always blame the woman,
Okay.
Bill cheated with Tom.
There you go. We don't know what happened, but Jill and Bill must not sit together now. So this is a great example of the not strategy, because it's going to be quite difficult to count the ways that Jill and Bill don't sit together. But it was easy to count the ways that Jill and Bill did sit together. In part A, we counted that there was 48 ways that Jill and Bill sat together. If we can count all the ways and subtract the bad ones, we'll get the good ones. That's what the not strategy does. What are all the ways that they can sit on the bench? 5 people without any restriction would be 5, 4, 3, 2, 1, 5 factorial. The bad ways we counted in part A, we already know that that's 48. So if we do 5 factorial, which is 120 minus the 48, there would be 72 ways where Jill and Bill do not sit together. Lee and Amy might be sitting together, they might not be. But this introduces the idea of a grouping strategy. And so if we recap our strategies so far, we started off with our spaces, just normal counting in spaces. Decisions is number of spaces, choices goes into each of the spaces. Then we added restrictions. Earlier today, we had repetition or identical objects. What happens when you have the same letter more than once? And now we've looked at what happens if things want to be grouped together. The nice thing about the homework sheet that you have is that all the questions are mixed up. You don't know what strategy you need to use when. Sometimes a question uses a couple of the strategies. And so we have to work with that. So we're going to work some more on our sheets right now. And we have one permutation strategy left.